but now we're going to talk about solving rational equations. And I'm going to put something up here that I'm going to refer back to later, but for the time being, I just want to put it up and talk about a couple of little ideas. You know how, I hope, to simplify that. You would find a common denominator, and the common denominator would be the product of x minus 2 and x plus 1. Then you would put them together with the common denominator, which would mean you would multiply this first rational expression top and bottom by x plus 1. You'd multiply the top and the bottom of the middle rational expression by x minus 2. And you'd multiply the top and the bottom, and there is a bottom, of the third rational expression by x minus 2, x plus 1. Are you with me? You'd put it all together. This is different. The thing on the left is something that I would say simplify. The thing on the right is something that I would give you and I would say solve. And these two problems are as different as night and day in terms of what we're doing, in terms of what we want to find. What you want to find on the left is a simplified result. What you want to find on the right is a value for x that makes the equation true. There is no value for x on the left that makes this true because it's not an equation. That equals changes everything. The thing on the left is not an equation. It's just an expression that you can simplify. The thing on the right is an equation that you rearrange and solve for x. But here's the kicker. They're both going to involve using a common denominator, but we will use them for different purposes. The common denominator, which will be x minus 2, x plus 1, is used for a different reason in the left-hand side to simplify than it is on the right-hand side to solve. And you have to try to not confuse the two, because by the time we get to the exam, I will give people something like this on the left, and they'll be doing the stuff you should be doing on the right and getting the answer wrong, or vice versa. So I'm going to come back and we'll use this as an illustration in a bit. So solve and check for extraneous roots. Okay, extraneous roots are solutions you get to an equation that just aren't right. So how can you check for an extraneous root? You can do the work right, get your correct answer, and then put your correct answer that you think is right into the equation. And if the equation is true, then it is right. And if the equation is not, then it's extraneous and it's not a solution. So your textbook, and I would say probably most, I don't know about most, a lot of math teachers approach this as a very step-oriented procedure. Do this, do this, do this. I want to try to move you away from that. And first of all, this whole unit is about factors, so let's just take a minute before we try to solve this and factor everything completely. And I'm going to ask you to leave some space between the terms. Although I immediately see that we're going to end up rewriting this in a second, so you don't have to leave too much space just yet. So we've got it in factored form. You don't know why we've factored it yet. I haven't revealed that to you, but it's in factored form. Would everybody agree that's factored correctly? I like to put those lines through my z's because my z's otherwise would look like 2's. What's something we can do here that has nothing to do with solving the equation that will make our life a little bit simpler?
Reduce the 10 over 6 to 5 over 3.
Right, reduce the 10 over 6 to 5 over 3. Why not work with smaller numbers right out of the way, right out of the gate? And this, by the way, this is not anything new that I'm going to tell you. You've heard me say this before. When you're solving an equation, what you want to do is make the equation simpler. At any stage, make it easier to solve. Right? Turn it from a Math 11 question to a Math 10 question to maybe a Math 6 question. Okay? So we know that there's a factor of 2 in the 6 and a factor of 2 in the 10. So I can reduce this down, and I'm sorry, we're just going to rewrite it again. Make sure you leave the space that I talked about. This is going to be a 5 on the top and a 3 on the bottom. And it's equals. This has an equals to it. Now, I'm going to show you my line of thinking here, my line of reasoning, and then I will tell you what your textbook would tell you to do to solve it. And you may make the decision that you just want to memorize what to do. But I would rather you think about this and why we're going to do what we're going to do. What is the problem here? What is making this difficult for us to solve? And we've had this problem before. How could this equation be different and make our lives easier? Yeah.
If the plus 5 over 3 z plus 2 is on the other side of the equation.
Can you repeat that, please?
If the 5 over 3 z multiplied by z plus 2 is on the other side of the equation.
Turns out moving those terms around is not going to help us. It's just changing the appearance slightly. Any other ideas? If I gave everybody this quadratic equation, what's the first thing you would do? I hope. What's the first thing you do?
Multiply by this by 6, like the...
Multiply everything by 6.
Yes.
Why? Because we would rather not have denominators, right? But here it's obvious. You go, well, I'm going to multiply both sides of the equation by 6. So you would multiply this by 6, and this by 6, and this by 6, and this by 6. And that would clear out all the fractions, wouldn't it? So this is my way of thinking. We want to get rid of all of the denominators. So start wherever you want. I have a z plus 2 in the denominator here. I would much rather not have a denominator. So I'm going to multiply the left side and the right side by z plus 2. Right? And if you look at what happens when I do that, and I can do it because I'm multiplying left and right by the same thing, what's happening is, and I don't want to cancel anything yet, so I'm just going to point, is that z plus 2 on the top will cancel with that z plus 2 on the bottom. And this z plus 2 on the bottom will cancel with this z plus 2 on the top. And nothing cancels here, but so what? At least we've got rid of the z plus 2's on the bottom. But we still have a z minus 2 on the bottom. So I'm going to multiply that term, the top of that term, by z minus 2. But then I have to multiply every term by z minus 2. Now, at this point in time, do you see that this entire first term here, this entire first term that I'm indicating, will no longer have fractions? Okay. This is different than what we did yesterday. Yesterday you would multiply top and bottom by something to create a denominator. Here we want to remove the denominators. Do you agree that this term will no longer have a denominator? Because the z minus 2 will cancel with the z minus 2. Do you agree that this term will still have a denominator of 3? Well, let's multiply everything by 3. And again, I'm about to tell you what we could have done instead, which amounts to the same thing. What your textbook would say is when you have a rational equation, multiply both sides by the lowest common denominator. I mean, it turns out that 3 times z plus 2 times z minus 2 is the lowest common denominator. But as a teacher, particularly in Math 30, I will not be using that terminology. I'll be saying, well, we have, look at that, guys, we have a sine squared of x on the bottom. Let's multiply both sides of the equation by sine squared of x. And we have 1 minus cos x on the bottom of this term. Let's multiply everything by 1 minus cos x. Things get maybe too complicated to start worrying about common denominators. So what happens? Be very careful with your canceling. Cancels, cancels. 3 cancels with the 3, z plus 2 with the z plus 2, z minus 2 with the z minus 2. Let me highlight for you what we have left. What you have left is this 2 and this 3, this 5 and this z minus 2, the z plus 2 and the 3. Okay. That gives me 6 plus 5 times z minus 2 equals 3 times z plus 2. And if you make a mistake, it's usually here where you missed something. Because you got all this stuff you've added and you've canceled stuff. Just make sure you've got it all. 2 times 3 is 6. Gone, 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 gone. 5 times z minus 2. It looks okay. And now this is a grade, well, grade 10 is being generous. It's a grade 9 equation. It's going to be linear. It's not even quadratic. 6 plus 5z minus 10. I'm just doing a bit of distribution there. Equals, same thing here. I mean, part of me just wants to say, let's move on to the next example. But let's finish it. If I move my z's to the left, I believe I get 2z. If I move my numbers to the right, I get 10. Don't just be a passive learner, as if there is such a thing. Don't just sit there passively. Work it out in your head. Follow my math. Is that correct? That 2z will equal to 10. Well, I just said 6 on both sides cancels to give 0 on both sides. I moved the 10 over. So z is 5. I know we're supposed to check for extraneous roots, but let's just park that on the side and come back to it, okay? Any questions with what we're doing here? We're multiplying everything by the common denominator, I suppose, in order to get rid of them. Any questions with any of the work? Okay, so if I go back now, everybody, to this, there's a big difference between what's going on here. Here, you would be multiplying top and bottom by x plus 1, top and bottom by x minus 2, and top and bottom by x plus 1, and x minus 2. I'm a little crowded here, so I'm going to fix this. If I said simplify, whoop, that doesn't work. If I said simplify this expression, you would end up with this. That would be, it's not your answer because you have to multiply all that stuff out on the top and see what happens. That would be your answer. Your answer is an expression with a denominator. Here, if I multiply both sides by x plus 1 x minus 2, what happens is I get 3 times x plus 1 plus 4 times x minus 2 equals that. I'm going to get an equation that I solve. Look at these things. This is different. This is an expression. Here you're going to end up with x equals a number. Looks like you're going to get maybe 2 numbers because it's quadratic. So huge difference. Let's try another one. B. And we're only doing 3, A, B, and C. So we need to, if you take my approach, we need to multiply everything by whatever is necessary to get rid of all the denominators. But in order to see that clearly, you need to factor. And again, I like to leave lots of room here because I know I'm about to multiply everything left and right by something. Oh, this is great. Because in order to get rid of the x minus 3, x plus 2 on the bottom of the right-hand side, I have to multiply both sides by x minus 3, x plus 2. But how many of you see in doing that, we will also get rid of the other denominators? I mean, that's kind of the point. So again, when you're solving a rational equation, you're multiplying everything by, left and right, by the common denominator so that you can do this. Resulting in an equation that doesn't have fractions, which is simpler to solve. So I have 3x times x minus 3 minus 5 times x plus 2 equals negative 25. I guess we can't really decide what to do unless we expand this out. As soon as I do that, you probably saw it right away, I'm starting to see I'm going to get a quadratic equation. So multiplying through, that negative in front of the 5, that's carried with the 5 when you multiply it through. Sorry, I lost my train of thought there. I just want to double check that. I think that's okay. It's quadratic, so we zero it. That's what we learned. And that's what we've been doing for a very long time. So I get 3x squared minus 14x plus 15. Would you agree with that? But there's a big mistake. Equals 0. Don't lose sight of the, because what might happen is if you forget the equal 0, you might look at it and go, oh, okay, I'm done. I've simplified it. We're trying to solve for x. So I'm glad that I'm seeing some of you grab a calculator because I'm assuming you're calculating b squared minus 4ac. 476. No, I could be wrong.
16.
16. I don't know what I was thinking there. Oh. I just so you know, I was using a negative with the 15. So it's 16. It's factorable. It's factorable. There's no common factor, by the way, so that's actually helpful to us. Because that means it's got to be 3x and x. I'm guessing it's 3 and 15. That would be what I would try. And the 3 can't go with the other 3, so it's got to go here. And this is 5. And if these are both negative, jackpot. When I said jackpot, I'm foiling it out and seeing that I do, in fact, get negative 9x on the outside and negative 5x on the inside, which is negative 14x. So 3x minus 5 equals 0. And x minus 3 equals 0. That tells us that x equals 5 over 3, and x equals 3. Any questions with that example? Oh, we're not moving on yet. We're not done. Because this is wrong. Why is that answer wrong? Faisal.
We haven't found the extraneous root.
So how would we go about doing that?
Wouldn't you just put in the equation?
Okay, good. Does anybody else, when I said why is it wrong, can anybody else answer why it's wrong in a different way?
One of the factors, or one of the fractions, was x minus 3 is a denominator, and 3 minus 3 is 0, so you
Right. In other words, there's a non-permissible value up here, right? When we factored all of this, and we saw that we had x plus 2, well, that's not allowed. That's not allowed. I'm not going to worry about the third denominator because it will contain an x plus 2 and an x minus 2. So to check for the extraneous roots, we can do what Faisal suggested, which is to go ahead and put each of the answers in, or simply go back and look at the non-permissible values. And if one of your answers is a non-permissible value, you have to strike it from the list. So since our equation had a non-permissible value that x cannot be equal to 3, we can get rid of that. There is one solution to this equation, x equals 5/3. It's why in the previous question I said, let's not worry about the extraneous roots, because I didn't want to give away how you would do it. If you look at the previous question, z is 5, correct? Is 5 permissible? Well, I don't know. Z is not allowed to be plus or minus 2 because of these two factors. That's it. Z is not allowed to be plus or minus 2. So if we got 2, we would throw it out. If we got negative 2, we would throw it out. Well, we got 5, and 5's okay. One final example. So even though there's nothing to factor here, I think it would serve us well to rewrite it so we have some space to put in whatever we need to put in. And if you ever find that you don't have enough space, I mean, I can move stuff around up here. If you ever find you don't have enough space, rewrite it. Erase it and rewrite it. Everything's factored, so I need to multiply by 2x minus 1 and by x minus 2. And I hope, how many of you are gaining an appreciation for the fact that I'm doing this because it will get rid of the denominators, but I'm multiplying by the lowest common denominator. Is that ringing true? However you want to look at it. So what happens is the 2x minus 1's cancel. The x minus 2's cancel. And we have, I don't know, I find if I get students to write out what's left and not multiply it through at the same time, they make fewer mistakes. So, we've talked about this before. You cannot do high school math without making mistakes. You can't. Even students I've had that get 100% on a diploma exam, they make a mistake from time to time in class. They write down the wrong thing. It's not possible to be perfect. But if you follow some of my steps and ideas, maybe you will make fewer mistakes. So that's what we have. Double check it. We have to expand that out. I think everybody here sees it's going to be quadratic, yes? Okay. So we have to expand it out. What do we get? 12x minus 24 equals 4x minus 2. And, you know, I get on autopilot sometimes, cruise control. I don't even think, so I should double check. That looks okay. It's not that you're cutting corners, you're being more efficient. I would probably multiply this out. Let's see, I have negative 4x and negative 1x is negative 5x, and then plus 2. You want to check my arithmetic there? Then I would multiply that by negative 5. All this stuff, I don't want to write it and then rewrite it again just to expand that. So negative 5 times 2x squared is negative 10x squared. Negative 5 times negative 5x is 25x. Negative 5 times 2 is negative 10. All right, now we're getting someplace. Double check everything. 12x minus 24. 4x minus 2. I'm going to have negative 10x squared. I'm going to have negative, positive. Negative 5x times negative 5 is 25x, and then 2 times negative 5 is negative 10. I think that's fine, yeah? All right, so I'm going to zero the equation by moving my quadratic term to the side where it becomes positive. A lot to keep track of here, taking care of that. What do I have? I have 4x plus 25x is 29x. So I have to take 12x minus 29x. I'm not really hopeful on the factoring thing happening here. Not with a number like 10 in front of the x squared and then negative 17, but who knows? Can you confirm, a couple of you, that it's negative 17x? Don't let me be the only one doing math. It is? Okay. And for my numbers, I already have negative 24, and I've got negative 12 on the other side, so I have to take negative 24 and add 12, which gives me negative 12. If this is factorable, I'll be surprised. And, you know, I'm the guy who made up the question, so you'd think I would know the answer to that or not, but I don't remember. I don't have that much time in my life that I can check over every lesson every day. 17 squared minus 4 times 10 times negative 12. Oh, I think it's factorable. No, it's not. I thought that was a perfect square. It looks like it should be a perfect square because it ends in a 9. But so, what does that mean? X equals negative b b is negative 17, so negative b is 17, plus or minus the square root of b squared minus 4ac all over 2a. So we get, this is interesting, we get irrational answers. And when you look at the original equation, it had rational non-permissible values. X is not equal to 1/2, X is not equal to 2. Well, neither of these numbers is 2 or 1/2. Can we simplify root 769? Like 9, it ends in 9. I'm wondering if 9 isn't a factor of 769. And, you know, for a math teacher, I'm bad with my number math. And so, no, it's not. 9, it's not divisible by 4. What else could it be divisible by? I think it's a prime number. It might even be prime. It's not divisible by 3, no. So that's it. This is our answer. 2 solutions. I'm not even going to rewrite them. Was it actually x? Yeah. X is equal to 17 plus the square root of 769 all over 20. X is also equal to 17 minus the square root of 769 all over 20. And again, these were our non-permissible values. Just help me out here. Just make sure that I am right. Are these the 2 non-permissible values? Okay. Well, neither of these numbers we got are equal to 2 or 1/2. If they were, then the thing would have been factorable, right? That's it. Tomorrow what we're going to be doing is word problems. I know you're all very excited to hear that. We're going to be solving problems that when you set up the equation to solve it, it turns out not to be a radical equation, not to be a quadratic equation, not to be an absolute value equation, but to be a rational equation. Okay?